I'm back at it again, you guys. I am going to be talking about, in this particular video, solving equations with variables on both sides, okay? So we worked a little bit in class with combining like terms. This is a skill that comes from 6th grade. I did a video also on combining like terms, so please check that one out. It should be in the listing there. But this is an offshoot of that, in that we need to try to remember or use the concepts that we've learned there in order to solve these equations, because once we combine those like terms, it's just like any other equation that we already know how to solve. Okay, so first things first, let's take a look at a presentation that I've done. This presentation is going to be in reference to how we actually go about solving those equations. Solving equations with variables on both sides is an offshoot, again, of 7th grade material that has already been learned last year. With that said, let's go ahead and take a look at the steps. First of all, set up your equation. You may draw a model to bridge the gap. Those models are going to be something that we have used in the past before, but this video is going to specifically focus on solving using the step-by-step methods of solving the equations with pencil and paper, basically. So no models in this particular video, okay? But if you know that method, please do so. By all means, draw that on any scratch paper that you have to help you understand the concept a bit better. Now, you will draw your lines and ensure that things are set up neatly. Now, this is going to be extremely important because of the fact that if you cannot see what you're doing, it's going to be that much more difficult to actually solve your equation. Now, the first goal is for us to combine our like terms. Those are those things that are the same. So say 8D and 10D would be terms that are the same. If I were to add those up, that would become 18D. Goal number 2 is to create a positive coefficient for your variable, if possible. And I'll show you exactly what that means in just a moment. So when I'm moving my variables around, I want to make sure that I try to create a positive coefficient so that I'm not dealing with a bunch of negatives. I would still get the exact same answer, but it's just a pain to deal with, so it's better if we combine them where the coefficient is positive. Once your terms are actually combined, you may need to flip your equation so it can look more familiar to you, and I'll show you what that looks like as well in just a bit, just in case that is going to be a preference of yours. Now, the next steps, of course, are going to be the same that they would be for solving any equation, creating your zero pairs, using the inverse operation to isolate your variables, and any checks that you may need to do. Now, remind yourself that inequalities, of course, are not going to have any difference in terms of solving. However, a negative coefficient will require you to flip the sign. Okay, so let's start off with our equations. All right, so I'm going to move this screen up a bit. Okay, so we're focused on what we're doing. All right, so next thing that we're going to, or the first thing I should say that we're going to look at is we're going to look to see where our variables are, okay? I need to put both of these on the same side so I can go ahead and start solving. As I said in the step-by-steps, am I going to move this over here? Or am I going to move this over here? Which of these is going to create a positive coefficient? Okay, so if I move a negative 5x, I'm going to have to add 5x over here, add 5x over there. That's going to create a positive coefficient. So again, it's sort of like creating zero pairs with variables in a way. Okay, so think of it that way. And I always want to make sure that I include my variable with that. I've seen some students just do it that way, but I don't want that to happen because you're going to confuse that with just a regular old number. So let's move everything. That becomes 5x. This is now 9x minus 24. Since this is now 0, this becomes 12. I'm going to move the 12 over. Okay, now it just looks like a regular equation. So I'm going to solve using the additive inverse first. This becomes 36. Let me make that a little bit straighter. Okay. Now, this is 0, of course. That goes away. This is equal to 9x is equal to 36. I'm going to use the inverse operation with my coefficient. This now becomes 4. Okay. So the value of x is going to be 4. If I were to plug this in back up here, that would give me that answer, okay? So I do, in fact, want to do a check. I'm going to do a check on one of these. The rest, I'm not going to do a check on, okay? You may do a check on my work or your work, but I'm going to check you, or I'm going to show you what the check actually looks like. I'm going to set it up with my original equation. I don't want to set it up with anything that I've done down here because there may be mistakes there. So I want to set it up with the original equation. The original says 4x minus 24 equals negative 5x plus 12. I'm going to plug in the value that or substitute in the value that I came up with. So negative 5 came up with 4 plus 12. I'm simplifying down. 16 minus 24 is equal to negative 20 plus 12, okay? So positive 16 minus 24 is going to be a negative 8. Negative 20 plus 12 will give me a negative 8. Is this statement correct? Is negative 8 equal to negative 8? Absolutely it is. That's my check. That's how you do your check, okay? Next, I'm going to move on to number 2 down here. So if I am looking at this properly, what I want to do is I want to try to combine these in a way where I'm going to create a positive coefficient for my variables. So again, my variables are here. So if I add positive 9x to both sides, and again, I want to draw myself a line here. I didn't do that in the previous one. Shame on me. All right, so 9x and negative 9x will equal a 0. This now becomes negative 9 is equal to 9x plus x. Now, this is assumed to be a 1 here. So if I have 1x or just x, which is what they say, 9x plus an x was going to give me 10x plus 21. Now, again, this just becomes a regular equation. Now, remember, this may not look like what you're used to where the variable is always over there, okay, with a constant. I'm going to do it so that you see exactly that you can do the exact same thing. In order to get this variable and coefficient by itself, I'm going to use the additive inverse. I'm going to add negative 21 to both sides. This becomes negative 30 is equal to 10x. Now, of course, to isolate that variable, I'm going to use the inverse operation. The inverse operation of this multiplication is division. I'm going to divide both sides by 10. Negative 30 divided by 10 becomes negative 3 is equal to x. If I were to flip this around, this means the exact same thing. And I'm going to do this at the very end. X is equal to negative 3. All right. Again, moving on to number 3. Let's look for number 3. Again, I want to create this. I want to move these variables around where the coefficient is still positive. So if I were to add negative 6x to both sides, again, using this line to separate what's over here and what's over here. Even if I do that, I am still left with positive 4x is equal to a negative 20. Okay. I'm going to use the inverse operation again. Inverse operation tells me that I'm going to do the opposite operation of 4 times x, which is division. This just leaves me with x. Negative 20 divided by 4 is going to give me what number? You guessed it. X is equal to negative 5. Okay. Now, let's go ahead and move on to one that's a little bit more difficult. Now, if with this is not already been presented in class, it's going to be presented in just a bit. This is using decimal coefficients, okay? So what I'm going to do at this particular time is I am going to, again, try to move the variables where I still am going to have a positive coefficient. Remember, the coefficient is just that number that's in front of the variable. So if I were to move 3.6x over here, I'm going to have to subtract or add negative 3.6 to cancel that out. If I were to do that though, if I were to add a negative 3.6x over here, there's only 2.8x over here. So that's going to create a negative coefficient. I don't want that. Okay. So I'm going to subtract or add negative 2.8x to both sides. Okay. This now becomes 0.8x minus, okay, 1.8 is equal to 5.4, okay? So my next step is, because it's just a regular equation now, a regular two-step equation, I'm going to add 1.8 to both sides. This, of course, is 0 now. This becomes 0.8x, and you can hardly see this x up here. 0.8x is equal to what? 7.2. Now, this is where my rational number operations comes in, my command of rational number operations. Due to the magic of YouTube, I'm going to divide both of these by this. Okay, now x is left over, of course, and I know that if I were to divide 7.2 divided by 0.8, that's going to give me 9. Okay, so again, if I were to substitute any of these answers back into the original equation like I did with this one, it's going to work out to be correct. Now, if any of this did not make sense to you, or if you wanted to just replay it to hear my voice again, go back over it, please do that. Okay. If you have any questions, of course, they can always be brought up in class. You may come to tutorials on either Tuesday or Thursday in the morning, or as always, okay, ask me again or just watch the video again, and hopefully it'll shine some light to you. I will see you guys in class tomorrow. That is all for now. Bye-bye.